slide to change. Okay, there we go. So the cloud promises several things, which can all be a driver to migrate to the cloud. For businesses, of course, lowering cost is always an important driver. Cloud can be a cost optimizer if you can really go to a pay-per-use model. The pay-per-use model aspect also means that you have lower risk because you don't have any investment that you have to worry about if you deploy stuff to the cloud, do new projects, do some proof of concept or something, or really move towards a cloud platform, a cloud service. Then because it's pay-per-use, you can always stop at a moment's notice. You don't have any investment up front. And this basically means for any business that they're more agile. They can try things, they can move in one direction and then change in another direction should the direction that they've chosen not be what they had in mind for it. And so with that in mind, you'll be able to get faster value because you can use existing cloud servers and combine those with new development. And lastly, you can benefit from quality of service, which for a large part has to do with scale and standardization. It's important to realize that the cloud is not just about outsourcing your IT function. For cloud providers to work efficiently and to be able to handle large-scale demand, they need to standardize. And this means that you have to settle for a standard. For any IT function or process which is not unique to your organization, this is a good thing. It means that you benefit from what others have tried and tested. But this only works if you're willing to acknowledge that for the most part, your organization is no different from the next. So there's really a different mindset if you want to really take advantage of the cloud promises. So the big question is, of course, how do you achieve these benefits? Should you start small or go for an all-out cloud strategy? And regardless of that question, where do you even start? There are so many things you can do with cloud that it's sometimes hard to figure out what the best way is to go in there. Take infrastructure as a service, for instance, which basically allows you to put virtual machines inside the cloud and run applications on them. They're a small step from on-premises. But on the other hand, the business perspective is gives the least benefits because you're still managing the infrastructure yourself. Not the hardware, but anything on top of that is still your own responsibility. So you don't have the benefit that other people are taking care of that, and that you can focus on what the function of the application is doing. On the other end of the spectrum, if you look at software as a service, it yields the highest degree of standardization of process, and that ultimately lowers your costs. Although this is still a difficult discussion, if you look at the pricing for a software as a service offering, then you might not think that it's more cost effective than keeping that same function on premises. The reason for that is that making a proper cost comparison is really hard. It's a skewed comparison, because assuming an organization can even quantify the total cost of ownership of a single application, which it usually can't, by the way, the cost comparison is based on a like for like. So what does it cost to maintain this application on premises versus what are the costs of this service for an X number of users for the entire year, and then comparing those two. But that doesn't take into account, for instance, that you get that you're far more agile in the way you deal with the application, and the fact that you may have at some point have a smaller number of users using the application during the year. For instance, for some applications, you'll have peak usage in certain periods of the year, and during other periods there aren't many users, so you can go down in the number of users and as such in the cost. Whereas you can't do that with an on-premises situation. So, as I said, software as a service is a very good option for processes that are not unique to your organization. In some cases, the customization options provide enough functionality to use a software as a service solution for more unique aspects of your organization, but for the most part, software as a service is all about standardization. So, if you can't use that, then you have to build your own software. Those are for your unique processes, and then you have a choice between using platform as a service or infrastructure as a service. For applications built on modern versions of platforms such as Java, .NET, PHP, platform as a service is going towards platform as a service is a really relatively small step, and it yields immediate benefit. The underlying infrastructure is completely managed, so maintenance effort and cost is next to none. In the Cloud Factory where I'm active, we currently manage a large number of platform as a service applications that have been transformed to platform as a service, which were previously on premises, and the maintenance cost on those applications is very, very low. Basically, the maintenance goes into change requests and so on. There is nothing or almost nothing that we have to do to keep the application running. That's the platform that takes care of that. Now, of course, not all applications are suited to run on platform as a service, even if they run on a platform for which PaaS environment exists, like Java and .NET. That's because a platform as a service environment enforces certain standards to ensure the stability, scalability, and security, and so on. Applications that don't follow these standards need to be modified in order to run on the platform as a service environment. So, in that case, what's an option, of course, is still running that on an infrastructure as a service environment, because that it more closely resembles an on-premises environment. Now, the difference between applications running on different cloud types is best illustrated with this diagram, which is basically the canonical cloud diagram to let people understand what the difference is between on-premises and the different types of cloud from the perspective of what function is whose responsibility. In an on-premises environment, all the functions are basically your own responsibility. Then when you go to a cloud provider which offers infrastructure as a service, then everything up to the operating system is a responsibility of the cloud provider. You're responsible for anything that runs in the operating system and on top of it. So if there's a security patch on the operating system, that's something that you have to do. And the same goes for the middleware and so on. Then when you go to platform as a service, you basically only have to worry about what your applications do and where the data goes. That's your responsibility. All the other things, so the platform that the application runs on, is the responsibility of the cloud provider. And then lastly, with software as a service, basically the cloud provider is responsible for everything functionally. You just take the service and use it. Now, this is the canonical diagram. The problem with this diagram is it's wrong. The diagram suggests that the different layers are the same across the different types of service, and the reality is far from that. To begin with, an on-premises hardware is high-end hardware with a low failure rate. So if you compare it to a fleet of cars, we're talking about a small number of Ferraris, Rolls-Royces, and Aston Martins that are very well tuned and maintained. And this is expensive. And they use top-line engineering to get the performance and so on that you want. Now, cloud infrastructure is something completely different. It's all about bulk. So it's usually cheap hardware that fails relatively fast, but it's also easy to replace. So if you look at the fleet of cars again, this is more like a fleet of small Fiats or small Chevys or something like that. They're small and they can't carry a huge load. They're not built for huge performance. But if one breaks down, we can get a new one in no time. So that's a big difference. And so the real picture really looks like this. So in infrastructure as a service, the virtualization layer is what it's all about. It manages that fleet of small cars and ensures that you get your VM quickly. So that's where all the complexity is, and it's what ensures that you can run your application on top of it. And then when you go over to platform as a service, well, really the middleware and the runtime is what it's all about. So the hardware and the virtualization that runs on is much less important. And that means that as long as the platform provides what you expect of it, performance-wise and so on, it really doesn't matter what's below. So, for instance, if you look at a platform as a service offering which runs a Java or .NET application, then in some cases you can't even go into a virtual machine or something. It's a shared environment, and or there's just multiple servers that are running it, but that's not visible to you as the consumer of that service. You just drop your application in the environment, and it'll run it. And it'll when you say, "Well, I want some more, I need some more scale," it'll scale. But in order to do that, it basically doesn't know. You don't know anymore what kind of machines are under there, and whether it's one machine or 10 machines. So that's something that you have to keep in mind when you create the application. So. Lastly, if you look at software as a service, there, of course, it's all about the application and the data, and there you have a lot of options with regards to the service that is provided to you. So the functions is what it's all about, and what that runs on, again, for you doesn't really make any any difference. If they're running that on, let's say, 100 mobile phones or on one big server, that's really of no consequence as long as the service provides what you want from it. So the moral of that picture, let me see, is that basically the cloud doesn't fit in your data center. Cloud providers are building services that have no equal in off-the-shelf software, either because the provider only wants to provide it as a service, or because it's so big it's unrealistic. So the example for a first one, for instance, is Salesforce, which says, well, we are a cloud company, period. We're not going to offer you any thing to work in your own data center. On the other example is Google Search or Bing. It really doesn't make any sense to put that in your data center because it provides vastly more services or functionality than you would ever want in your data center. So the other way around is also true. Your data center doesn't fit in the cloud. A typical company data center is conceived around different design principles than cloud data centers. In the past decades, local data centers have been designed to be highly reliable and to provide predictable performance for predictable workloads. Hardware is sized to meet peak demands, mostly by using scale up, so using larger machines rather than using more machines for the same thing. So more performance through faster hardware. Changes to a local data center are usually carefully planned and don't happen very often. The network infrastructure is hardware-based and it's therefore very static. Mainframes, for instance, are a very good example of systems that run stable for years. So it's just the applications that run on them, and it'll just keep working. So moving from there to something else really takes time and planning and so on. If you know your local data center has these characteristics, you typically design your applications accordingly. Because we know that the mainframe is always on and has a very low failure rate, we'll create an application that uses those characteristics. For instance, high reliability means applications can store state without having to worry about losing that state because of a system failure. In fact, to ensure consistency, it's not uncommon that applications lose their state on purpose when the system fails. So it actually, if it's in the middle of a transaction and the system fails, then we actually don't want something to happen with that in-between state. Cloud services are based on very different design principles. A cloud data center is changing rapidly to keep up with user demands, to enable more powerful applications, different network configurations, and so on. Where a local data center is defined by the hardware configuration, a cloud data center is dynamic and uses software-defined infrastructure. When the software governing this changes, so if you have a host where applications are sitting on, then and the host changes, then this has an impact on running applications. They have to be moved to other hardware before the hardware can receive the software update. Compared to a local data center, the change rate is high, and to facilitate this, the cloud services often use the destroy, redeploy principle. When changes or failures occur, the existing hardware is destroyed and new virtual hardware is created to take its place, and then we just redeploy the application to it. So that only works if your application is capable of dealing with that. So for one, if it takes, let's say, 2 to 3 minutes to destroy and redeploy your the application, then running your application on a single instance, so on a single virtual machine, well, that would mean your application is not available for 2 to 3 minutes. So you need to run it on at least 2 instances, so to ensure that the system can fail over to the other instance, and maybe even, let's say, in an update environment, say, well, I'll spin up a new VM, update it, and then I'll shut down the old one. So in that case, for instance, the state of your application is something you have to deal with, that it can fail over from one instance or node, or whatever you want to call it, to another. And so This really means that our applications are fundamentally changing in the way we architect them. And I'd like to call that the SMACT application architecture. Because basically what happens there is that what we've been doing for the last decades is that we've been building systems that work on a transactional request-response paradigm. So we do something, we request something, and we expect a response, and then when we get the response, we're expecting that the transaction has occurred and that it's stable, so that if at that point something happens, the system is in a consistent state. Now, the problem of that paradigm is that it doesn't scale well. If you have a transactional system, you need to keep the data consistent at all time, which means that, in a sense, only one person or only one thing can change the data at one time. And so for one user, that's fine. For 10 users, there's some locking involved, but it'll work fine. And we've come up to a point where we can even do that with thousands of users, but the world is a lot bigger place, and then if you get the Internet of Things, we're talking about an amount of data that we can't handle transactionally anymore. And we've seen in the last decade, we've seen the rise of NoSQL storage and so on, which is not transactional in nature. And the architecture that we're moving to is an architecture where we're not doing a request-response thing, but where everything's asynchronous. I do a request, and I'm not going to wait for a response. I might get a response somewhere down the line. And we're looking at systems that are what's known as eventually consistent. So they may not be consistent all the time, but they will be consistent at one point or another. And that's because we're working with notification and making changes to data at one point or another. So basically, we provide access to our applications. The applications are accessed either through a browser or an app or something, and that works through an API. And then we send notifications either to the devices that's working on, or to the application that really needs to store something. And so it becomes a distribution problem of getting the data to the right place and then processing it and then storing it. And then if you scale that out, you basically get to get sort of a circular system where you start off with sending a notification, distributing the notification for processing, then processing it, and then storing it and replicating that storage so that when people read it, there are multiple places they can go. So if you look at Azure, for instance, this is what that same picture looks like. And you see a lot of services that are in there, and those services are provided by the platform. They're not, there's no infrastructure that you see. The queue is just something that you talk to, and how that queue works underneath is not a really important thing, as long as you can rely on it being stable and being always there. So you see that the platform is really expanding our capabilities. So where we used to have a framework like the .NET framework or the Java framework, we now have a whole bunch of services that we can use in our applications to do whatever we need to do in our applications. So this change really is a very significant change in architecture, and that really has a great impact on how we look at transformation, because if I'm building a new application, I can use this new architecture, but if I have a lot of existing applications, then that's not possible. So the question really becomes, how do we deal with that if I have an existing company? And that's most of our clients. From a high-level perspective, there are basically three ways to migrate to the cloud. Businesses that see cloud as mostly an IT thing will typically tell the IT department to lower costs, and so that's a driver to go into the cloud. And this will result in an inside-out approach, starting with infrastructure transformation, basically replacing on-premises hardware with virtualized hardware in the cloud. And the idea of this approach is that for business users, nothing changes really. It's just moving IT to the cloud. The reality is that although migration of IT functions is taken up from the infrastructure side, the changes trickle upwards to applications and business processes. So ultimately, there are changes that are going to happen, and that has to do with the fact that as I said earlier, your data center is not the same as the cloud, and the cloud is not the same as the data center. So there are changes that need to be made in order for your applications to run properly. So another way to go at this is to approach the cloud as a way to transform the business. So you get an outside-in approach where you look at the business processes and transform these to make optimal use of cloud services. For the past year and a half, or almost 2 years, I've been involved with our Dutch mail company, PostNL, and they're the most extreme example of this. They've basically said that by the end of 2015, they no longer want to have local data centers. Everything needs to be in the cloud. And they're not just using this to change the way that IT is delivered to them, it's the way they change their business. And the reason for them is that their business is changing really rapidly. Traditional mail is ever declining, and it's being replaced by digital media. And then on the other hand, the parcel delivery is skyrocketing. They set another record this Christmas. So for PostNL, just changing the IT infrastructure is not enough. They have to be able to downscale their systems with the decline of the mail market, but at the same time have to be able to keep up with peak loads during Christmas and so on. And so they're changing the way the company works, and the cloud is facilitating that. And this also means that some applications are no longer needed, and other applications require major changes or can be replaced with other applications or software as a service offerings. In many companies, using cloud services from a business perspective is not directly a conscious choice, but rather something that happens because the IT department fails to deliver. It's quite common for departments within an organization to use services such as Box or Dropbox, Google Apps, Office 365, or Salesforce because they have an immediate need, and in some cases the IT department doesn't even know. They just grab a credit card and get the service. And so these are the two outside ends of the scale. And if you look at the middle, you also have application transformation. And if you choose that entry point or that strategy, if you will, then basically you're looking at a dialogue between your business and your IT, and then applications can be transformed from an IT perspective to yield the wanted results. And in other cases, the business process can be modified and application may be replaced as a result. So those two can work in conjunction. So then if you look at the approach, then you can basically go from a top-down perspective, where, well, like the example of PostNL, where you go completely into the cloud or partially into the cloud for certain processes, or you can do a bottom-up approach where you do partial stuff for specific scenarios. So business applications with a typical cloud patterns, so bursting cloud patterns where at one point or another you have a lot of users for that application, or generic applications like mail and collaboration applications, CRM, and that sort of thing. They're also available from the cloud as software as a service. And what's booming at the moment is storage and disaster recovery and backup in the cloud, because a lot of organizations are struggling with having 2 data centers and keeping those in sync and so on, and then being able to go into the cloud where you're basically paying, not paying for a second data center, but just for the disaster recovery services. The cost of that environment is a lot less than keeping around a second data center. And so Microsoft just announced new capabilities for backing up virtual machines, either that are in the cloud or that are on premises, and you can scale up to the cloud from within your own data center. And those are scenarios that really help you understand what's going on and get familiar with using cloud services. And then the last one, which is really interesting, is dev test and training environments in the cloud, and that's one of the things that I work on a regular basis. We have we're building within SogetiLabs the one share service, which is our dev and test environment service from the cloud. And what we achieve with that is that started off as an internal thing. We had development teams and test teams that had changing populations, and so we had to add a developer. And what happens at that time is that so a developer added to a project has to repave their machine, change configuration, and so on, and that can take up to 2-3 days before a developer gets to what we call the time to first meaningful activity. That's a long process. So we started by getting our developers active in the cloud and let them create a machine there. And the next step we did is we automated that. So what we do now is we create a template for a development machine for a specific project, and then when a new developer comes in, we basically provision that machine from the template, and he's up and running within 15 minutes. So the time to meaningful activity goes down from several days to, let's say, 30 minutes. And the same goes for testers and so on. And because we have those templates, we can easily create a large number of environments, so for a training environment as well. And we're expanding on that service constantly. So it's built on top of Microsoft Azure, and we utilize the services that Azure provides, and then expand on that. So regardless of the approach, it's important to think about how your applications keep working together. So before you move one application into the cloud, you really need to stop and think and look at your entire portfolio and your entire application landscape and see how will that integrate, how will they keep working when I move one or a few applications into the cloud, and to what extent is that necessary? For some applications, it may not be necessary for you to for them to really work together. You can just use those. Let's say your CRM, if that's really a separated function, then you can easily move that out. You'd still need to think about how people log on, because you don't want users that are no longer with the company to be able to still log in onto your CRM system. But this is a hard piece of the puzzle to tackle, because our on-premises environments over the last decades have become sort of a fortress where there's only a few ways in and out, and those are heavily guarded. And so now we get to a point where we're placing our applications or part of our application landscape outside the walls of our on-premises environment. So we're getting outside of the fortress. So how do you still secure those applications, and how do they communicate in a secure fashion, either through VPN or HTTPS? And identity plays a very, very, very important role in that. If you don't have that solved properly, then that's going to be a major issue. So that's one of the first things you need to think about and tackle. So once you've taken care of that, you've taken care of, let's say, the prerequisites for your environment to move parts of it to the cloud, then you can start to look at the individual applications. And to minimize complexity, it makes sense to do this in clusters of related and interconnected applications. And that way you stay in control over the connections between on-premises and cloud, and between clouds if you're actually using multiple cloud environments. So for each application, you have to determine which way to take the application, and we classify these with what I call the 7 or 8 R's. So retire, of course, means, okay, we don't use this application anymore. We can replace the application if it's not something that's very specific to our business, and then a software as a service offering can be a very good option. So, and then I'll go down on the scale first and say we can retain it, of course, on premises. Another option is to rehost it or re-platform it, which basically means we're picking up the application as is and putting it in an infrastructure as a service environment, either by just picking up the VM and moving it, which is something that's really an option. There's tooling that allows you to just move it from one place to another, and not even with a disruption of service, it stays on, or re-platform it, in which case you are updating the operating system and so on. Now, the last thing is refactoring or rebuilding the application. So refactoring is taking the existing application and changing it a bit in order to be successful on the cloud. So for instance, taking care of state issues or encryption or security type issues, and then deploying it on the cloud. And then rebuilding, if you have an old COBOL application, for instance, on a mainframe, then refactoring obviously is not going to work, so then you'll have to rebuild. And then revise is somewhere in between. You do additional changes on top of refactoring to get your application more suited for the cloud. Refactoring is something that you really need to do. And if you look at your entire portfolio, then some of these steps can be in-between steps. So you can first re-platform or rehost an application, and then start working on extending it once it's in the cloud environment. So for instance, in Azure, once you're in the infrastructure as a service environment, you can extend your applications with platform as a service offerings, like using the queue or using certain kinds of storage and that sort of thing, to start using the platform more and more, because that's basically where the benefit lies. So determining whether your application is cloud ready has basically two aspects. There's a legal part and there's a technical part. So the legal part is, is it allowed by law to run this sort of data and have this sort of data in the cloud, and that sort of thing. I won't deal with that here. It's something you really need to look at from a legal and governance perspective. The other aspects are, of course, performance and scalability and reliability, and for a lot of people, the most important one is security. Is the cloud secure? Well, in my opinion, it's probably more secure than a data center, because it's got a lot more scale, and cloud providers usually have a whole army of people that are looking at just how do we keep this thing secure, how do you ensure that the data of our clients stay secure, and how do we ensure that nobody that isn't allowed can access that data. So that brings us to the architecture for cloud applications. So if you look at applications, you have an existing application which you want to transform, then there's really questions of, does it support web farms, and are the network protocols suitable to run in the cloud, and how does it deal with date and time, authorization, and that sort of thing. And so these are all the things that we need to look at when we pick up an application and transform it. We really have to refactor an application to ensure that these aspects are covered so it'll run in the cloud. And so when we look at an application, then we use this flowchart to determine where we want to, where we think the application should go to. So the first question, of course, is, do we have the source code available? Because if we don't have the source code available, then we only have the binaries, and then we have certain restrictions to what we can do, what we can install it on. In most cases, that means it needs to go in infrastructure as a service environment. And then if that isn't supported, well, then we're out of luck. We can't put it in the cloud. If we do have the source code available, then we can look at whether or not we can make that application run on a platform as a service environment, either by refactoring it or by rebuilding it. And because we have the source code available, rebuilding an application becomes a lot easier. So coming back to it all and looking at the steps to take when you want to move into the cloud is, first look at, okay, why do I want to do this in the first place? Is it just to save costs? Is it to save costs? Not all, the cloud is not by definition cheaper, especially if you have a production environment that's always on, then from an infrastructure perspective, the infrastructure as a service isn't likely going to be a lot cheaper, and you still have your personnel around that need to maintain everything. But the improved agility and so on can make up for that and save cost in the long run. So if you've decided on that, then the next question is, okay, how are we going to do this? Are we going to go private cloud? Are we going to do public cloud? And are we going to go for software as a service as much as possible, or are we approaching this from the bottom up and leveraging infrastructure as a service first? And how are we going to deal with integration, orchestration, and that sort of thing in order for your applications to run? Then you look at your application portfolio and look at the how you're going to transform those. There are bound to be patterns in those, because unless you've been only been doing just something, your application portfolio is likely divided in groups. So most companies have a strategy where they say, well, we standardize mostly on .NET and Java, or on Java and PHP or something like that. And we standardize on specific databases and that sort of thing. So what that allows you to do is to cluster those applications and create patterns, and those patterns will help you to quickly transform your applications. So then you start selecting those, get the quick wins, set up your factory to transform those applications, do a few, either in a proof of concept environment or just by doing it, and then you'll find out what works and what doesn't work, and you can tune the change. And then, of course, then you're in the cloud, and then your operating model becomes different, and you'll have to think about how you're going to further enhance your use of the cloud. So the key takeaways for this session for me are, the first thing is get your goals straight. Why are you doing this in the first place? Because that really determines the strategy that you need to take in order to transform your application portfolio. Then the second thing is, it's the platform, stupid. Cloud is not just another place to park your applications. There's a platform, and it's really different in compared to traditional applications. And if you really want to build custom applications, then you need to make use of that platform. And for default business functions, you use software as a service. So to know what goes into software as a service and what goes into the platform is application assessment, application portfolio assessment. That's really a key step to take to understand what you have and where that needs to go. And then once you've done that, ensure that your transformation is industrialized and predictable. If you have more than 10 applications, then doing all of them just one by one is just not an option. I'm currently involved with a project where we're talking about tens, maybe hundreds of applications, and for PostNL, that was also at the start of this journey, they had 400 applications. That's not something that you can transform into the cloud without setting up some kind of industrialized process. So that's it from me. If anyone has any questions, please unmute or use the chat window.
Well, Michel, we don't have much time, but I'm going to quickly ask you one question. That is, what is your opinion on device-based cloud security vulnerabilities? For instance, iCloud photo, video leaks, and stuff like that.
Okay, so I'm going to answer that in a little more in a broader perspective. Because basically that's the question of, okay, how secure is the cloud, and how secure are my applications that are run on that? And so the thing is that from a infrastructure perspective, our environments have really changed. So, but from an infrastructure perspective, we're pretty safe. The environments that we're creating are a lot safer than most on-premises data center. It's the thing is that iCloud, for instance, they had some security issues recently, and that's like a plane crash, you know. It gets publicized very much because this is iCloud, this is Apple, it should be secure, and so on. But the fact of the matter is that if you would use your own environment, then there's much more likely something that can go wrong than in an environment such as iCloud, because as I said, there's a whole army of people that look at that, and they won't make the same mistake twice. And as a smaller company, you just don't have the luxury of having so many experts running around to deal with that. So that doesn't mean that they don't have a responsibility, of course, but it's something that's top of mind. If you look at devices and the way that we can secure them now, that's really just at the beginning of where we can go. There are biometrics involved and so on, and then there's also we have a lot of options these days that if I lose my phone, I can wipe it remotely and so on. So I don't really see that there's a security problem there. Does that answer your question?
Yes, Michiel, thank you very much. So anybody has any other questions, please feel free to ask, because we don't have much time. And if you don't, then you can ask any question you might have to Michiel directly. You might email him if you have any question. Yeah? So I suppose that's it for today. Thank you very much, Michiel, for that wonderful session. It was very insightful indeed.